Hello everyone. So I'm back with another video which is on kinematics, what we have done previously. The equations of motion, the distance covered in nth second, and Galileo's law of odd numbers. And what are we doing in this video? In this we will solve the assignment or the practice questions which were given in the last video. What you should know is the first equation of motion v equal to u plus at. The second equation of motion s is equal to ut plus half at square. The third equation of motion v square minus u square is equal to 2as. The distance covered by a body in nth second, that is dn is equal to u plus half a into 2n minus 1, and Galileo's law of odd numbers, which is the distances traversed during equal intervals of time by a body falling freely from rest, stands to each other in the same ratio as the odd number, starting with unity, that is 1 is to 3 is to 5 is to 7, and so on. Now these were the first 6 questions. If you wish to try, pause the video, try the questions, and then play it again to check the answer. The next 4 questions. The 10th one is a very good question. You should try on your own. Question number 1. A stone is thrown vertically upwards with an initial velocity of 14 meter per second. Find the maximum height reached and the time of ascent. So this is the stone. Okay, it moves with initial velocity 14, reaches maximum height. So u is 14, g is minus of 9.8. V is 0 at the maximum height. So using the third equation of motion, v square minus u square is equal to 2as. We put the values and find s is equals to 10 meters. So this is the first part, that is maximum height is 10 meters. Okay. Now let's use the first equation of motion, that is v equal to u plus at. V is 0, u is 14, a is minus of 9.8, and we can find t is equals to 1.43 seconds. Question number 2. A player throws a ball upwards with an initial speed of 29.4 meter per second. To what height does the ball rise, and after how long does the ball return to the player's hand? Take g is equals to 9.8 meter per second square. So let A be the point of projection and let B be the maximum height attained by the ball. So we have A and B. The ball is at point A. It goes to point B. So u is 29.4 meter per second, v is 0 at the top, a is minus of 9.8 meter per second square. Let's use the third equation of motion, that is v square minus u square is equal to 2as. Let's put all the values, and on solving we get s is equal to 44.1 meter. That is, we have found the height to which the ball rises. Now let us find out the time also, after which it will reach the player's hand. So time taken to move from A to B. Let's use the first equation of motion, v equal to u plus at. On putting the values we get t is equals to 3 seconds. That means in moving from A to B, the ball took 3 seconds. Now moving from B to A, it will again take 3 seconds. So the total time for the ball to return to the player is 3 plus 6, that is 6 seconds. Question number 3. A car moving along a straight highway with a speed of 126 km per hour is brought to rest within a distance of 200 meter. What is the retardation of the car and how long does it take for the car to stop? So u is given 126 km per hour, that is 35 meter per second. V is 0 because it stops. S is 200 meter. So this is the car moving with 126 km per hour. Okay, in 200 meter it stops. So let's use the third equation, that is v square minus u square is equal to 2as. We put the values and we find out that a is minus of 3.06 meter per second square. Now we have to find the time. So let's use the first equation, that is v equal to u plus at. Let's put all the values and solve to get 11.1 seconds. Question number 4. A balloon is moving upwards with a speed of 5 meter per second. When it is at a height of 98 meter, a packet is dropped from it. What is the velocity of the packet when it strikes the ground? So this is the balloon. Okay, it is moving upwards with 5 meter per second. The height is 98 meter. Now a packet is dropped. Now the balloon is moving upwards with 5, and if the packet is dropped, so the velocity of the packet is minus of 5 meter per second. So what is given? U is minus 5, G is plus 9.8 as the packet is moving downwards and the distance is 98 meters. So let's use the third equation of motion, that is v square minus u square is equal to 2as. U is minus 5, so v square minus 5 square is equal to 2 into 9.8 into 98. On solving we get v is equals to 44.1 meter per second. Question number 5. From the top of a tower 100 meter in height, a ball is dropped and at the same time another ball is projected vertically upwards from the ground with a velocity of 25 meter per second. Find when and where the two balls will meet. So this is ball A and this is ball B, and this is the point at which we suppose that the balls are meeting after t seconds. So for ball A, u is 0 as it is dropped. Distance we say is x, and g is 9.8 as it is moving downward. So it moved from A to C. We covered the distance x. So let's use the second equation. S is equal to ut plus half at square. So x is equal to 0 into t plus 1 by 2, that is 0.5 into 9.8 into t square. That gives x is equals to 0.9 t square. We name this as equation 1. Now for ball B, u is 25, the distance is 100 minus x, and g is minus 9.8 because it is moving upwards. So it moves. Okay. Now again we will use the second equation of motion. So 100 minus x is equal to 25t plus 0.5 into 9.8 into t square. That is 100 minus x is equal to 25t plus 4.9 t square. Now in place of 4.9 t square we will put x from equation 1. So this becomes 100 minus x is equal to 25t plus x. We get t is equals to 4 seconds, and from equation 1 we can find x, that is 4.9 into 4 square, that gives 78.4 meters from the top. Question number 6. Two trains A and B of length 400 meter each are moving on two parallel tracks with a uniform speed of 72 km per hour in the same direction, with A ahead of B. The driver of B decides to overtake A and accelerates by 1 meter per second square. If after 50 seconds the guard of B just brushes past the driver of A, what was the original distance between them? So this is train A, this is train B. The distance, let us suppose, is S. Now this is the question. Now the initial velocity is 72, that is 20 meter per second for both. Time is 50 seconds. A for B is 1 meter per second square. Now for train A, the distance covered is 20 into 50 plus 1 by 2 into 0, because there is no acceleration for train A, into 50 square, that is 1000 meter. For train B, it is 20 into 50 plus half into 1 into 50 square, that is 2250 meters. Now comes the most interesting part. Now what is happening, that train B is overtaking train A. So what is the total distance covered by it? It is equal to the length of train A plus length of train B plus the original distance between them. That means the distance traveled by B minus distance traveled by A should be equal to the original distance between the two plus the length of both the trains. So when we put the values, we find S is equals to 450 meters. Question number 7. A body moving with a uniform acceleration travels distances of 24 meter and 64 meter during the first two equal consecutive intervals of time, each of duration 4 seconds. Determine the initial velocity and acceleration of the body. So this is the time axis, this is the body. So in the first 4 seconds, it covers 24 meters. That is, time is 4 seconds. S is equal to ut plus half at square. So 24 is equal to 4u plus half into a into 4 square. That gives u plus 2a is equals to 6. We name this as equation 1. Now in the next 4 seconds, it covers 64 meters. So I can say from the beginning, it covered 88 meters in 8 seconds. So time is 8 seconds, distance is 88 meters. We will use the second equation of motion again. So S is equal to ut plus half at square gives 88 is equal to 8u plus half into a into 8 square, which gives u plus 4a is equals to 11, equation number 2. So equation 2 minus equation 1 gives a is equals to 2.5 meter per second square. From 1, u is equals to 6 minus 2 into 2.5, that gives 1 meter per second. Question number 8. On a two-lane road, car A is traveling with a speed of 36 km per hour. Two cars B and C approach car A in opposite directions with a speed of 54 km per hour each at a certain instant. When the distance AB is equal to AC, both being 1 km, B decides to overtake A before C does. What minimum acceleration of car B is required to avoid an accident? So this is the two-lane road. This is car A moving with a velocity VA, which is 10 meter per second. This is car B moving with a velocity VB, and car C moving in an opposite direction with respect to B with a velocity VC. VB and VC are 15 meter per second. Now the relative velocity of car B with respect to A, as they are moving in same direction, so we will subtract to get 5 meter per second, and the relative velocity of car C with respect to A, as they are moving in opposite direction, so we will add and we will get 25 meter per second. Now we know when AB and AC are equal, then C is also moving. So what is the time taken by car C to cover distance AC? So that is T is equal to AC upon VCA, that is 1000 by 25, that is 40 seconds. So to avoid an accident, car B must cover the same distance in a maximum of 40 seconds. So S is equal to ut plus half at square. So the distance is 1000 meters because it was 1 kilometer given in the question. U is 5, T is 40 seconds, and we find A is equals to 1 meter per second square. Question number 9. A parachutist bail out from an aeroplane, and after dropping through a distance of 40 meter, he opens the parachute and deaccelerates at 2 meter per second square. If he reaches the ground with a speed of 2 meter per second, how long is he in air? At what height did he bail out from the plane? So this is the plane, this is the parachutist, he drops. Okay, so he covers a distance of 40. So in case 1, that is when he drops, u1 is 0, g is 9.8, s is 40. So let's use the second equation of motion, that is s is equal to u1 t1 plus half a t1 square. Let's put all the values and solve to get t1 is equal to 2.86 seconds. Now let's use the first equation of motion, that is v equal to u plus at. Here it is v1 is equal to u1 plus at1. Okay, so we put all the values and we get v1 is equal to 28 meter per second. Now when he deaccelerates, The final velocity in the case 1 changes to the initial velocity in case 2, that is u2 becomes 28 meter per second. The final velocity is 2 as given in the question. A is minus 2 again given in the question. So he opens the parachute, he comes down. Now let's use the first equation of motion. So v2 is equals to u2 plus at2. We put the values and find out the time, which is 13 seconds. Let's use the second equation of motion. S dash is equal to u2 t2 plus half a t2 square. We put all the values and we found that S dash is 195 meters. So this is 195 meters. So the total time of the parachutist is t is equal to t1 plus t2, that is 2.86 plus 13, that is 15.86 seconds. And the total height of parachutists bailout is, yes, 40 plus 195, that is 235 meters. Now question number 10, a very interesting question. Drops of water fall at regular intervals from the roof of a building of height 16 meters. The first drop striking the ground at the same time as the fifth drop detaches itself from the roof. Find the distance between the separate drops in air as the first drop reaches the ground. So let's try to visualize. This is the roof, this is the ground, and these are the 5 drops, namely d1, d2, d3, d4 and d5. Okay, and this is the visualization of the question. Let s1, s2, s3 and s4 are the distances of drops d1, d2, d3 and d4 from the roof. Now this can be understood in this manner that all the drops are coming from one point itself. So instead of, I have taken 5 separate places, you can take at one point itself. This is better visualization, that's why I have taken this part. Now clearly the first drop covers a distance of 16 meter. Let t be the constant time interval after which a drop detaches itself from the roof. So 4t is the time interval in which drop d1 covers distance s1, 3t time interval in which drop d2 covers distance s2, 2t is time interval in which d3 covers distance s3, and t is time interval in which drop d4 covers distance s4. Now let's use the second equation of motion. S is equal to ut plus half at square. Now as it is dropped, so u is 0. So we get S is equals to 4.9 t square. Now for drop D1, S is 16 meter, T is 4t. So S1 is equal to 4.9 into 4t whole square, which gives t square is equals to 1 upon 4.9. Continuing the answer further, this was the visualization of the question. Now for drop D2, S is S2, T is 3T. So S2 is equal to 4.9 into 3T square. That is 4.9 into 9 into T square. That is 4.9 into 9. And we put the value of T square as 1 upon 4.9 and we get 9 meters. So S2 is 9 meter. For drop D3, S is equal to S3, T is equal to 2T. S3 is equal to 4.9 into 2T square, that is 4.9 into 4 into T square. We put the value of T square and what we get S3 as 4 meters. Let's find for drop D4, S equal to S4, T is equals to T. So 4.9 T square and we put the value of T square as 1 upon 4.9 and we get S4 as 1 meter. So the distance between D1 and D2 is 16 minus 9, 7 meter. Then the distance between D2 and D3 is 9 minus 4, that is 5 meter. And the distance between D3 and D4 is 4 minus 1, that is 3 meter. So now is the acknowledgement. This presentation is meant for students of class 11th. A few images and data are taken from Google and Bing, for which I am thankful to both. Thank you so much for watching the video.